Hi, I'm going to talk to you about how a mechanical clock works and some of the physics behind it. So let's get started. So this is a diagram of a mechanical clock, and I know it looks really scary, but we're going to clear everything up. So there are two really important parts of a mechanical clock, and one of them is the mainspring, which is right around here. The other one is the pendulum, which is right around here. So the mainspring's job is to basically give the clock its energy to turn the gears and to move the minute hand and the hour hand. So it's basically what lets the clock move. Um, and the pendulum is what gives the clock its ability to tell the right time. The pendulum basically sets a pace, and it's what lets the gears turn at the right times, which lets the hour hand and the minute hand turn at a consistent pace as well. And that's what basically lets your clock tell time in an accurate way. So this is a closer look at what a mainspring looks like. And it's important to emphasize that a mechanical clock does not work with electricity. So you can't use a battery and you can't plug it into the wall. Instead, in order to power a mechanical clock, you have to use a special key called a winding key. And use that key to wind up the mainspring. And as the spring tightens, it creates potential spring energy. And that just basically means that when the spring unwinds, it releases kinetic energy, and that turns the gears and it moves the hands of the clock. So once again, um, the mainspring, when it's super tight after you tighten it with the winding key, is full of potential spring energy. When it starts to work in the clock, it the spring starts to unwind and it starts to loosen up and it releases kinetic energy. And that's what turns the gears and moves the hands on the clock. This is a diagram of a pendulum, and there are two forces acting on a pendulum. One of them is tension. So between the fixed point and the weight at the bottom, there's tension on the wire. And that just basically lets the whole pendulum stay together so the parts don't go flying everywhere. The other force that's acting on the pendulum is gravity. Gravity is basically what lets the pendulum swing, and especially at such a consistent rate. So when the pendulum swings upward, there's the force of gravity, or the force of the earth pulling down on the pendulum, and it starts to slow down up until it comes to a stop right here. And then when it comes to a stop, it's full of gravitational potential energy because it has all this way that it has to come back down. And that's exactly what it does. It starts to come back down and it starts to lose potential energy and gain kinetic energy. When the pendulum comes right here, it's full of kinetic energy, but it has no potential energy. But because it has so much kinetic energy, it's moving at such a fast pace that it comes right back up and it does the same thing as before. It slows down until it comes to a stop. And here, because it's not moving, it has no kinetic energy and it has a lot of potential energy. And it just keeps doing that. Um, but the weight, because the pendulum doesn't change its weight, and because the Earth's gravity is always consistent, the time it takes for the pendulum to go one way is the same time it will take it to go back the other. And a whole journey of a pendulum one way and back is called a period. So if if I said a pendulum's period was 4 seconds long, it would take it 2 seconds to come to a stop one way and 2 seconds to come back. And the pendulum is basically what lets the clock run at the right pace. And the pendulum is swinging inside the clock. So this is what lets the minute hand and the hour hand tell the right time and do it at a consistent pace. So I hope this was helpful, and thanks for watching.